Okay, let's begin our next example. Again, we have a concave mirror. This time we're going to put the object between R and F. And I've saved a little bit of time by drawing the object already and showing the shading. Namely, this means that to the right of this picture, to the right of that mirror, light never actually goes. So let's look at our three rays. The first one is the undeflected. And that one goes through, well, from the last example, I see that it goes through the near radius. Here's that radius. Whoa, that's going to be steep. So it doesn't really start at the radius, but if it were starting at the radius, it would go through the tip of the arrow like this. So I'm going to draw this thing here. That's coming from the radius, and then the arrow goes like this. And eventually, off screen here, way up there, it's going to hit this red vertical line, and then it comes back undeflected. So that means it comes back like this. So I can at least draw that part. So it goes out like this, and it comes back like that. So that's our number one. Now, number 2 and 3 are the two rays that have in common that there's a parallel beam parallel to the axis, and there's some action through the near focal point if it's a concave mirror. So let's just draw the incoming parallel beam like this, and it gets to that red line, and then what? Well, the normal at the surface of the mirror is going to be pointing downward a little bit, which means that there will be a deflection towards the axis. Now, there's got to be a focal point in this one because there's a parallel incoming, so it's going to be this focal point right here. So there's our ray doing this. Let me relocate number 1 up here. And this one right here is going to be number 2. Oh, I better do 2 up here as well. So there's number 2. Parallel incoming. Goes out through the near focal point. Now, what about number 3? It's going to be a parallel outgoing. And if I wanted to cheat, I could say, well, these two are definitely, clearly hooking up over here. They're crossing at that point. So that's where the image ought to be, and there's where the tip ought to be. So any outgoing parallel should go through like this. So it should hit the mirror just about there. And what hits the mirror just about there? This ray going through the near focal point. So here we go. And then outgoing, it goes like this. This is one of the reasons that we draw 3 principal beams, is so that we can check that we didn't screw up with either of the first 2. We want consistency. We want a beam that, well, we want all beams to go through a single point over here. Now, that's going to be the image, so let's draw it. In this case right here, it's hitting the axis about this place. So there's our image. Draw the tip of the arrow. IMG. Now, you tell me which of these things are true for this image. Is it real or is it virtual? Pause if you have to think about this. Well, it's real because those beams actually do meet. Is it upright or inverted? Yeah, inverted. Is it enlarged or reduced? Oh, this is actually larger than the object was, so it's enlarged. So now we've done another one of these, and it's always the same 3 beams. The third one was incoming through the near focal point, and it's parallel outgoing.